Hi, I'm Erin,
I'm Connor.
Yeah, and you're here representing the junior high math team. And we're just going to kind of talk about math and reading, the highs, the lows, the in-betweens, and see what we can do to kind of help this be relevant immediately to this subject area. So my first question for Connor was, why is math so hard?
It's a funny question, and I don't think it has to be hard, and myself, I don't think that it is hard, but I think there's some misconceptions about how things are done in math and how things are taught that actually, despite our best interest to try to make it easy, we're actually doing the opposite. And so the idea that math is hard for some people and that some people just aren't able to succeed in math, all of that is kind of a myth and a misconception that exists.
Yeah, but I think it's it's not just in the math teacher community. I heard from students so often, right? I'm good at math, so I'm not good at good at English. And then students also saying, I'm good at English, so I'm not good at math. They always seem to be.
There's even a compounding problem of parents who feel that because they were not good at math, that their child will not be good at math.
They can't help their kids.
Right? And I always make the connection to, what would you say to a parent if a parent ever said, well, I never could read well, so I don't expect my child to read well. That kind of idea.
Yeah.
I'd always kind of make that connection with parents and saying, if you're illiterate, does that mean that your child will be illiterate? Or if you're, lack numeracy, does that mean that your child must lack numeracy?
Statistically, it kind of does indicate that. That's something that I've learned from Lisa Boussier in her research, right? That if you do have a parent with reading difficulty, this child statistically will be more likely. But I think it's just because of time spent.
That's right.
It's not genetic.
And the same could be said about math. If that math is not, if that time's not spent early on, even in developing counting strategies, sometimes that can delay a student even as they get into kindergarten, grade 1. Yeah. And then there's that misconception that exists that, well, I'm not a math person, I'm not good at math, and that whole works. So.
Okay, well, let's get into reading in junior high math. So, I don't know if I would say how important is reading to junior high math, because I would predict the answer is it's not. So how can those things work together?
So recently we brought in a speaker. Her name was Pam Harris, and one of the things that she spoke about was that when we teach, if I use an English language arts class as an example, if we teach writing, we actually get students engaged in the process of writing. Mm-hmm. If we teach reading, we actually get students engaged in the process of reading. What we're teaching actually is almost a vowel. It's an action. But then she raised the question, well, what do we do in math? Do we get kids engaged in mathing or doing math, or what's the verb that goes along with it?
Adding.
Right? Well, that's one part of math maybe. Yeah. But so I thought that was kind of an interesting thing. And she spun it in a way saying, well, what we should be doing is getting kids engaged in the work of a mathematician. And so she tried to kind of relay what is the work of a mathematician, but where I'll make the connection to reading there is that in order to be a mathematician, if you ever kind of speak to a mathematician, they are very comfortable in the context of math. And so part of that process is actually being able to read and interpret the variety of texts that exist in math. So we often as teachers will tend to kind of focus on word problems and say that's the aspect of reading is word problems. But we can bring in a lot of different strategies that talk about all the different varieties of text and representation in math. So when we talk about even their ability to read a diagram, read a graph, read any visual representation, all of those things actually have skills that then can be kind of transferred into other domains and other areas. And so
because when you say text in math, it makes me think textbook. What are other math texts?
So what I mean by saying text, I mean anything that's providing information in terms of if we talk about reading a table of values, the strategies that I might use in reading a table of values is going to be different than maybe the strategies that I would use in reading a graph. Mm-hmm. It's also different than maybe the strategies I might use in reading a word problem.
Yeah.
Or, we even get it going to higher level mathematics that, reading and interpreting mathematical proofs become something that gets involved in
text.
All the strategies that we kind of develop in reading all those variety of texts, they play a part. So if I think, again, I'll try to make the connection to English language arts, just because that's you.
Yeah.
In English language arts, you'll spend time exploring, the structure of poetry. You'll spend time exploring the structure of maybe a play or a novel,
visual,
or anything
can
along
be a
that.
text. Yeah.
So I think in math we have to actually do that same piece. And I was reading a little bit of research trying to get ready for this, and I read something that says actually most learners and even most adults, when reading through different types of text, will often skip titles. Mm-hmm. And I thought that was kind of interesting. Mm-hmm. I think that problem actually gets compounded a little bit in math, because not only will people skip the titles, they will gravitate right to the numbers. Mm-hmm. And so even within the body of text or the body of writing, they will look and try to pick out those numbers. Yeah. And so there's a lot of studies being done about what they call numberless word problems, mm-hmm. where the student actually has to interpret what is the problem asking before gravitating to those numbers.
Yeah. That's interesting. Can you talk a little bit more about that? I'm sure where that would fit in, like to places, I guess, and the outcomes that, is that something
like the numberless word problem?
Yeah, is that like explicitly named in your curriculum?
No. So a numberless word problem, though, it's something that can be used to develop the strategy of interpreting and solving word problems. And so in one of the articles written about it, it talked about how students will gravitate to those numbers. And so even generally, students, when they gravitate to those numbers, their first initial instinct is to actually add the numbers. And that's just because it's the easiest operation to perform. Like you said, I don't know, in math we add. That's so what a numberless word problem does is actually takes away the numbers and says, things like, instead of Erin has 5 bananas, Erin has some bananas, and Connor has some bananas, and how many bananas do they have all together? Or what's the difference between the number of bananas? So instead of being able to gravitate to those numbers and say, well, I just want to add the bananas, or I want to subtract the bananas, or whatever, they actually have to interpret what is the problem asking us to find, and then allows them to infer, well, what would be the numbers that I would need in order to actually answer the question.
So 2 things, I think as a student, that's something that I would enjoy more, because then I'm not pinned to that one answer. Right. But I think that that would be tough, because you would have as much variety in the answers that you get from students, right? Some students like a large amount, a larger amount, several, for
That's right, but it's not even focusing on the quantity at that point. It's just focusing on what information do we need and what do I actually have to do? Mm-hmm. So instead of saying, well, you have some bananas, I have some bananas, we're going to have a lot of bananas, right? It's more, if we're looking for the total number of bananas, well, I need to know how many you have, I need to know how many I have, and then I'm going to add. So,
okay, so this, again, not devil's advocate necessarily, but math devil's advocate, how do you mark something like that?
Well, I think it's more, rather than looking at it as kind of that assessment piece, it's more of a developing the strategies. So I would look at it as more of kind of a formative piece, and looking at how can we actually develop those strategies. If I did want to bring it into kind of that, that summative piece and looking at actually, grade their progress on it, mm-hmm. it's where I'm now actually looking at the communication piece, having them describe to me what their strategy would be, and to interpret, are they interpreting the problem correctly? That's where now that kind of grading piece would come in, where it's not looking at, okay, did they get the correct answer, but it's looking at, do they have a strategy that would actually lead to an answer, and are they able to communicate that strategy? And that communication piece is one of the 7 math processes we have in our program of studies. So them being able to describe their strategy is a piece of that communication. And so whenever we think of communication, we tend to go to that symbolic pen and paper, they're able to, show me your work kind of thing, but it can be that verbal communication as well. Right, it could be written, it could be written, it could be anything, because again, the whole, to bring it back to the purpose of this project, I guess, which is the reading, right? That would be a way to get words in front of your students, and also to bring to the awareness of the math teacher in the classroom, this student struggles with words, which means I have to give them more words to read, more exposure, more practice, not less. That's right, yeah. So I think, though, mentioned the textbook, right? If those numberless word problems aren't in a textbook, or if they aren't in the curriculum explicitly, that's kind of an obstacle for a teacher, right? So it can be, so what are those things that a teacher has to kind of deal with when it comes to implementing reading into their classroom? Well, I think there's a couple answers to that. One of the big obstacles is they will look at it as just, it's another thing I have to teach amongst all the outcomes that I have to cover. We ran into that even a little bit with our calculator-free assessments and those strategies, and we were talking about how could we bring in strategies of reasoning, just so that instead of having students 100% reliant on a procedure, how could we develop reasoning? And we had teachers that saw that as, well, that's now adding another week to every one of my modules where I have to discuss those strategies.
Right.
And the same would be said about reading. So they'll look at it as, well, that's another week that I now have to bring in every time. And so
time is kind of an obstacle.
Time is definitely an obstacle. And so I think the way to maybe kind of look at it instead, and it's the same with those calculator-free kind of foundational strategies, is we need to find ways to incorporate this in kind of our everyday instruction where it doesn't feel like it is that, extra week that you have to kind of add into the program of studies.
Well, and this is why I'm kind of like forcing everyone to sit through like understanding the science of reading, right? It's
right.
Like you can't kind of just make a change without understanding the philosophy or like the neuroscience or the explanation behind it. So it's kind of, I guess it's going to come from the understanding of what has to be done and what a student needs, not so much just like do this task, do this activity.
Right.
Yeah.
So I think the way that I would kind of look at that is, again, if we go back to that idea of like being a mathematician, there's skills that we can develop in terms of exploring that variety of different math text. And so, I think of one unit in particular that some of our students struggled on was actually stats and probability. And stats and probability is one where the actual math is really ingrained in the context. And so there's a lot of that interpretive piece that has to happen. But not only is there that interpretive piece of like word problems, stats and probability, we use a lot of graphs. We use pie charts. We have a lot of students that can't actually interpret correctly a pie chart.
I would say that does that unit maybe rely most on background knowledge than any of your other units to understand kind of the context where this pie chart would exist?
If we're talking background knowledge in terms of like the context outside of math, then yes. But in terms of like mathematical background knowledge, it's actually one of the smaller ones.
Oh.
It would be something like number would be much more heavily reliant on kind of what they explored at the elementary level, where stats and probability is not as heavily in, especially our junior high curriculum in that regard. But in terms of the context piece of it, that's where it becomes kind of that massive, so it's not even just looking at a chart or a graph outside of context. It's now the ability to not just, find a number on the chart that some students are able to do, and a lot of students are able to do that if you just ask them for a particular number. But where stats and probability comes into play, that actually becomes more difficult. It's interpreting that number. What does that number mean? What does that number, how does that number relate to the context that we're talking about?
Right, and then explaining it relies on that communication that you were talking about.
That's right. And so that connection is where the struggle really is. And that's why, the reading strategies that we can bring in, and how to read a graph, how to read a table of values, how to read, a chart, a pie graph, all of that stuff, we always want to relate it back to, okay, now, so we found a number, what does that number actually represent? What does that number mean?
Yeah.
Whereas when we live in the number strand, we'll do calculations, we'll do addition, subtraction, multiplication, division, but it's not always in that context. And so that's why even our calculator-free assessments, they're all the foundational skills that are outside of that context. So we never ask them to interpret what that number represents. That's a heavy piece on the stats and probability side. And I mean, you can make a nice connection to that idea that people often skip over titles. Like just think about on a graph how important the titles are, not even just the main title, but the title of all the axes and everything like that.
No, that's huge. So I'm not sure if there's anything else that we haven't covered, like kind of talked about things that we know teachers are struggling with, places where in the curriculum there is a connection to reading that's a little bit simpler, but what was...
I think the other aspect that I would bring in is the idea of, what are the kind of words that we're using in the classroom. So if we talk about kind of from the mathematical context, we have a few things. We have words that describe procedures, and I don't mean just procedures like to add and subtract and multiply and divide, but we get into things like compare. So like, what does it mean to compare in math? And that definition actually might even be slightly different than what it might mean
to compare in
English. we get into kind of very content-specific words as well. I think one of the challenges, and I know this challenge exists in all subject matter areas, but in math I can think of just off the top of my head of a few concepts that actually have a much more specific meaning or even a different meaning when they're used in the math context than they might be used in regular English or common English or whatever
Which
we want to.
Which is super confusing, not just for a student who struggles with reading, but for a student who's learning English at the same time that they're
So one of the texts that I was reading actually talked about how every student in their own way is actually a language learner when you're within a context. So I went and thought of an example. So if we take a grade 9 outcome that we have, it talks about, demonstrates an understanding of rational numbers. So just in that, when we talk about rational numbers, okay, so if I'm an English language learner, I'm thinking, well, an irrational number, when you start thinking of a number that's irrational, in common language, you'd think like,
how, a megalomaniac.
How is this number irrational? But it has a very specific meaning in math, and it does.
Yeah, I was thought this is even probably simpler than junior high, but even the connotation behind positive and negative.
That's right. Yep.
Right? Like that means something completely different in math, really, because it's not pointing to like value judgment. It's just where it is on a number line.
That's right. Yeah.
Where in English, it's like positive affirmations or negative space, right? For sure. Completely different.
For sure. So in saying that, I think generally what we'll do as math teachers is we want to gravitate to those content-specific terms. So if I'm reading that outcome, I will probably gravitate to the word rational number and say, okay, I'm teaching rational numbers. But if you look at the actual outcome, it talks about comparing and ordering. So I would want to actually explore some time, what does it mean to compare in math? What does it mean to order? It talks about solving problems. What does that mean in terms of actually, how do we use rational numbers to solve problems? And so the outcome's not to just describe rational numbers, but it's how do we use those rational numbers in different ways. And so I think we generally, when we talk about vocabulary in math, we want to gravitate to those like, well, I'm teaching rational numbers. I have to give them a definition of rational numbers, which is fine. But there's also those verbs that are in there that we want to kind of build that understanding in students as well.
Yeah. So I guess it's knowing, just being aware of those words that we don't find particularly challenging, like to say out loud or to remember because we use them all the time, but just that they have different definitions in different contexts.
More specific sometimes, or like you said, even different. Yeah.
Yeah, and just to be aware of that. Great. So is there anything else you want to add?
I think that's pretty good.
Great. Well, thanks for taking the time, and thank you.
Pleasure.
You all were forced to be here, but thanks for paying attention. And yeah, that's it.